All right, 4.3, multiplying and dividing rational expressions. Okay, so good news is this one's actually not going to be very different from just simplifying like we did in the last one. So for example, let's go way back. Let's say if we had an expression like this, if I had like 3/4 times, and let's say 2/6, right? And we were multiplying these guys. Well, multiplying is the easy one, right? It's not like adding and subtracting. Adding and subtracting, you have to figure out that whole common denominator and everything. But with this one, it's just straight across, right? So this isn't too bad. This would just be 3 times 2 is 6. 4 times 6 is 24. And then you could simplify that, right? You'd be like, okay, well, you could simplify the top, simplify the bottom there. So divide by 6, divide by 6. So end up being 1/4, right? But we can do the same thing. I just want to show you a little easier way here too that we could have done that we're going to do a lot more now. You can just multiply that straight across if you like. But the other one that'd probably be a lot more valuable here is I can see that when you're multiplying, you just have stuff in the numerator and you just have stuff in the denominator. And when you're multiplying, it's like they're one thing. This that I'm looking at right here would be exactly like 3 times 2 over 4 times 6. It's the exact same thing, right? So there's just stuff in the top and stuff in the bottom, right? So right from step 1, we could have started canceling things because I can say, well, if I look at like the 3 and the 6 here, then I could say, well, I could have just canceled 3. Like 3/6 would be the same thing as 1/2, right? Like that would become a 2 on the bottom. And then I can see I've got a 2 on the top and a 4 on the bottom, so I could cancel those. That's like, 1. That become a 1, and that become a 2. So then in the end, all I have left is I've got 1, right? Just that one, over, and then 2 times 2 is 4. It does the same thing, but this way we're going to use a lot more, especially because we're dealing with variables now. So let's throw some variables in because I think it'll make more sense. I'll stop erasing now. I'll keep it on here. So yeah, so for these ones, what we're going to do is it's going to be something like this where it says simplify. Right, so we're going to simplify these. So number 1. So it could be a question like this. B over 12 times 3a over 2b squared. Okay, so now, like I said, I can multiply straight across on the top and bottom if you like, but it's gonna make things a little like it'd be fine. Now you can cancel it after, but I'm just gonna start canceling things now, right? I've got a b on the top over here, and I've got a b on the bottom over here. I can start canceling that, right? That's the same thing as like b over b squared, right? Even though they're on other sides of the equation, there's just a b on the top over here and a b on the squared on the bottom over here. So all of that would become, well, the b would cancel with like one of the b's there. So I've got like one b left on the bottom. And then I could take this 3, right? There's that 3 there and that 12. I could think of that as being like 3/12. So I could simplify this. I could cancel that 3. And so this would be 3/12 would be the same thing as 1/4, right? That 12 would become a 4. And then just write what you have left. So this would all be the same thing. And typically this is the way you want to do it. You want to work your way down for these expressions. So then in the end, we'd say that we had, we would have just a, right? I've just got that a left on the top, over, and then 4 and a 2 on the bottom. That would become 8 because I'm multiplying. And then I've still got a b. And that's it. So it's a lot like simplifying, right? We just got that multiplying in between there. So, all right, let's do another one. Number 2. So let's say we had 6m cubed times n plus 1 over 15m times n plus 1. It was all of that. So normally, right, from the last lesson, we could just cancel those. But here, our whole expression, we're going to make it big and long here. So it's x, or sorry, not x, that's going to be times. And then 2n minus 1 over m times n, right? All right. So this would all be the exact same thing as without the multiplication symbol, right? It would just be all this stuff on the top, like everything on the top on both sides and everything on the bottom on both sides, right? They could all be like sandwiched together if you like. And we could even write it that way. Maybe I'll do that maybe for this one, right? We could cancel right now, but I'll show you that it would be the exact same thing. It'd be the exact same thing as if we wrote it like this. I could just multiply the 2 and the 6 right now. So that'd be 12m cubed times n plus 1 and then n minus 1. That's just like all the stuff on both sides all sandwiched together. Over. And then on the bottom, we'd have 15m. 15m. And there was m times m, I guess. So we could say that was m squared. And then we still had an n. And we had an n plus 1. Okay, now this is straight up from what we did last lesson, right? So we start canceling. So I've got like an n plus 1 up top and an n plus 1 on the bottom, so they cancel. I've got an m cubed up top, so that would cancel 2 m's on the bottom, and you'd be left with 1 m on the top. And then I've got 15 over 12. Well, 3 goes into both of those, so I can divide the top by 3 is going to be 4 over 5, and then I've still got an m up top, and I've got an n minus 1, and then on the bottom I've still got that n. So there you go, that'd be it. Hopefully that's making sense for you guys. Let's do another. Actually, you know what, and while we're doing this too, we should be talking about our non-permissible values. So remember, non-permissible values are saying what is m and n not allowed to be. So the only time we run into a problem here is with our denominator. So what is m not allowed to be? Let's do m first. M is not allowed to equal, and I'm asking myself, what would m have to be in order to make the whole thing equal to 0? Well, it can't be 0, right? Because if m itself, if I threw a 0 into that, that'd be 15 times 0, which would be 0. And then that 0 times this is still 0, right? That would make everything 0. So m's not allowed to be 0, okay? And then the other part of this would be n. So n is not allowed to be, well, if I look over here, right, it's not allowed to be 0 again because of that. So it can't be 0. But then it also can't be, and I'm looking at this one this time, right? If n right there, if that was -1, well, then that'd be -1 plus 1. That would make this 0, everything in brackets there, which would make my whole bottom 0. So n is not allowed to equal -1. So those would be my non-permissible values there. Okay. Hopefully you guys are finding more room than me. Let's do another. So 3. Okay, so let's say we had x squared over 6. And instead of a time symbol, I'm going to go like a dot, right? So I don't get confused with the x's I was already putting there. So 2y over 3x. Okay, so again, I could sandwich them all together, but really I can cancel these just the way they are. So let's do the x's first. So I'm going to say, okay, well, I've got x squared and I've got an x down there. So I can cancel like one of these x's, right? So the squared would cancel with the one on the bottom. And then if I look at my 6 and my 2 there, right, that would simplify to 1 over 3. So everything up top here, I've really just got x, y, and I could say 1 if you like, over, and then, you know, so that was a 1 and that was a 3, right? So then 3 times the 3 that's already down there is just 9. All right. Now, so that, what we were doing here so far was when it was already kind of set up for you, right? We didn't have to factor anything. So now what we're going to throw into it is factoring as well. So we're going to have to factor these things before we get going. So if we had this question, let's say, so we had 2x squared minus 12x over 15x times 5x over x minus 6. Okay, so this is one of those weird situations where I can't just say, okay, well, there's an x and there's an x, I'll cancel those, right? You can't do that. And the reason for it is because this is a binomial, right? There's like 2 different pieces up top, right? It's both of those over 15x. So I can't just pretend it was only in that one, right? So I have to, well, what we have to do here is we have to factor everything to see what's actually common to the top. So I'm going to factor the top there. So we'll say, well, what's common to 2x squared and 12x? Okay, well, 2x's. So we're going to write that as 2x. I'm going to start my bracket and then write what I have left. So after I factored out 2x out of 2x squared, right, I've still got x left. And then minus, and then 12 divided by the 2 I took out, so that's 6. So that's my top. And then the bottom, I can't factor that, so I'm just going to write it again. So 15x times 5x over, and then this worked out nice, x minus 6. And that is like it's in brackets, right? That's all over that, right? So that worked out nice because now this is free game. I'm allowed to cancel this whole x minus 6 and x minus 6. Okay, so they were written the same way. I can also, here, just do the one of them there. I can also cancel this x with, well, one of the 2 x's up there, right? I can cancel with this one and that one. And what else? So now we've got the 5 over 15. So I could cancel that 5 and that would become 3 on the bottom. And then if I just write everything I have left here, after I've canceled it all, I've got left 2x over, and then I just have 3 left on the bottom. Okay, and then technically I should say my non-permissible values. My non-permissible values here would be, well, x is not allowed to equal, and I want to look up here, right? I want to look there and I want to look there before I cancel things. So because of this one, x is not allowed to equal 0, right? Because if that was 0, then I'd be dividing by 0, so it can't be 0. And on this one, x right there is not allowed to equal 6, because if it was 6, that'd be 6 minus 6, that'd be 0. So it can't be 6. Okay, so there's my answer for that one. All right, now let's do some maybe a little bit tougher ones where we got to factor a little bit more. So one sec, all right. Okay, so let's do, sorry, I'm just looking for a good example here. There we go. All right, so now, so what was that? That was 4. We'll do 5 here. All right, so let's say we had x plus 4 over x minus 1 times x plus 1 over, and then here's where it's going to change up. We've got x squared plus 5x plus 4. All right, so these ones I would leave, right? You can even put brackets around these if you like, because it's kind of nice to think about it as like a thing, right? You just got like, that's like one packet, that's like one thing there. It looks like I could almost cancel like the x minus 1 and the x plus 1, but they're not the same, so I can't cancel them. But now the bottom, right? That doesn't look quite right. But what I can do and what I have to do is I've got to factor this first to see if there's anything I can cancel out of this. So we're going to write it all again. We're going to write it as x plus 4 over x minus 1 times x plus 1. And then I'm going to factor the bottom here. So the way we factor these ones, right, where you've got a squared and then an x and a number on the end, is they just both get a bracket, right? Bracket, bracket, and they both get an x. And we're looking for numbers that multiply to 4 and add to 5. Okay, well, that would be 4 and 1, right? And then they both be plus. And then that worked out well, because now I can see, well, x plus 4 would cancel with x plus 4. X plus 1 would cancel with x plus 1. And all of that cleaned up really nicely, because now on the top, now this throws kids off too, right? I've got like nothing left up there. So this is where people would be tempted to say my answer is just x minus 1. But that's not right, right? Because x minus 1 is in the denominator, right? That's in the bottom. So I've got nothing left up top, but there really is something there. There's really a 1, right? There's still a 1, even though we canceled everything out there, right? So there's 1, and then it's over x minus 1. So that would be my final answer there. And then again, for the non-permissible values here, we should have been stating those too. You can do that at the beginning as well. But again, what I want to do is I want to look at it before I canceled things. And I think I want to look at it right here, right? Because it's actually a lot easier to see what my non-permissible values would be. So I'm going to say, okay, x is not allowed to equal, and then I can see from this one, it can't be equal to 1. I can see from this one, it's not allowed to be equal to -4. And I can see from this one, it's not allowed to be equal to -1. So those would be my non-permissible values. It can't be equal to, you could write it like this, like 1, comma, -4, comma, -1. It doesn't really matter, but you could also write it like this, where it's 1 plus or like plus or minus 1 and 4 and -4. So either one, is not allowed to equal. Okay, so you guys will have to do that factoring in these questions. It's not too bad. Usually you'll know, because you'll factor it and then things start canceling. You'll know you probably did it right when you're able to cancel 1 or 2 things. All right, so that is multiplying. Now, I haven't done division yet, but division's actually going to be, there we have more room. Nope, well, I do down here. Okay, so division is actually going to be pretty easy as well. So let's do like a little review of dividing fractions in general. So let's say if I had 3 over 4 divided by, let's go 3 over 2, right? If I was dividing those. So here's the thing to remember. Dividing by a fraction is the same as multiplying by the reciprocal. I know that sounds confusing, but what that means is that if I'm dividing by a fraction, that would be the exact same thing as going 3 over 4 and then changing it to a multiply. So multiplied by, and then the reciprocal are these two numbers flipped upside down. So that'd be the same thing as 2 over 3. Okay? So then at that point, you could say, okay, well, I got 3 over 3, those cancel. The 2 and the 4, but that would all just turn into a half, right? So that would just be with a standard fraction. You guys did that in Math 9. Now we're going to be doing rational expressions with it. So that's taking that same idea. Now let's do one like this. So we'll say, what number are we on? 6. So if we had 12x squared over 15, and now it's divided by 3x over 2y. Okay, so now we're going to say, okay, we need to, well, this one's not too bad. We just change it right off the bat. So we're going to change this to, well, you keep the first one the same. Don't flip the first one, because it's just you change the second one. So we're going to keep this as 12x squared over 15. Now I'm going to make this a multiply, but then these two guys flip. So this will be 2y over 3x. And then it's just like the last things, right? Now it's just like the question we just did. So, okay, I've got x squared up top, so the squared would cancel with the x on the bottom. And then I've got, well, really just this 12 over 15. 3 goes into both of those. So we still are left with, so 12 divided by 3 is 4. I still error. I'll just do 2 steps. 4, there's still the 2y up top, over, and then you've got 5 divided by the 3 that we did there would be 5, and then I've still got the 3 on the bottom. And then the x is gone, right? Oh, sorry, I forgot the x up top. There was still an x on there. It looked like I crossed it out. There was still an x up top. Okay, so that would all be equal to 8xy over 15. That should be it. Okay, and then technically though, we still, again, we should have been doing our non-permissible values, right? So let's go back up and see what's not allowed to equal what. So if I went right to the beginning, right? Let's go right back up to the beginning. So I'll say, well, there's nothing even in here, right? So I don't got to worry about anything like dividing by 0 there. But right here, I can say, okay, well, y is not allowed to equal 0, right? Because if that was 0, I'd be dividing by 0. But here's what the other tricky part about this is the one to remember with division, is after we flipped it, right? So it wasn't allowed to be this because we couldn't divide by 0. But watch what happened after we flipped it. Now the x is on the bottom, right? So x is also not allowed to equal 0 because now it's in the bottom there, right? So when you're doing division, you have to take into account on the second term, like on this term, you have to take into account like what is x or y not allowed to be on the bottom, and also on the top there, because the top on this one is going to become the bottom on the second move there, or on the second, like after we flip it. Okay, so you got to look at both there. Okay, all right, last one. We're going to do one more question here, and then we're done. Okay, so that was 6, so we'll do 7. All right, so we've got x squared minus x minus 20 over x plus 4, and then divided by x squared minus 3x minus 10 over x minus 1. Okay, so now we could flip this right now and write it all again, but you know what I'm going to do? I'm going to kind of flip it and factor it at the same time, just so we don't have to write it all like twice or like another 2 times. But so here, I'm going to start factoring as I go here. So I'm going to factor this top one. So that would be, so I'm just going to write my brackets. They both get an x. And now I'm looking for numbers that multiply to 20 and add to, well, 1, right? There really is a 1 sitting there. Okay, so multiply to 20, add to 1. I'm just going to, so about 4 and 5, right? So 4 and 5, which is promising because the difference between 4 and 5 is 1, which I want. And I need to multiply to a negative. So one of these guys has to be negative and one's got to be positive. All right, so it's got to be this one, right? This has to be negative 5 and positive 4 because they need to add to negative 1. Okay, and then that's over x plus 4. And then I'm going to change this right now. I'm going to change this to multiply and then flip these guys, right? I'm going to factor it at the same time. So on the top, we've now got x minus 1. And on the bottom, I'm going to have this part there, right? So that'll be, well, I'll put my brackets down. I'm looking for numbers that, so they both get an x. I'm looking for numbers that multiply to 10 and add to 3. So probably 5 and 2. And then one's got to be negative, one's got to be positive to get to that, multiply to negative 10. So this will have to be negative 5 and positive 2. Okay, so we're looking good here. There's lots of stuff to cancel. So now, well, actually, yeah, we'll come back and do the non-permissible values after. So we'll cancel now. So now at this point, I can say, well, I've got x plus 4 on the top and x plus 4 on the bottom. So those cancel nicely. And I've got x minus 5 and x minus 5 on the bottom. So all of that cancels. And in the end, all we have is x minus 1 over x plus 2. And that's it. And then you'd say where x is not allowed to equal, so where x is not allowed to equal, and then let's look back up here. What was it not allowed to equal? So from the beginning, right there, right, x is not allowed to equal -4, right? It can't be equal to -4 there. So it can't be equal to -4. Looking at this, x is not allowed to equal 1 because of that one. But then here's where it changed, right? Because normally I wouldn't even care what was on the top at the beginning, but that got flipped. So now it's on the bottom here. So now I do have to take this into account. It's not allowed to equal -2 because of that one. And it's not allowed to equal 5 because of that one. So it's not allowed to equal +5. So there you go. There'd be your non-permissible values for that one. Okay.